In a previous video, I mentioned or treated the topic of handling arguments in Bash. And I introduced a few topics like if statements, the test command, but I didn't really have the time to explore them in detail. So I thought I'd make another video, kind of explore them and teach you guys how to use these effectively, or at least a little bit, give you a little bit more background on what's going on. So my name is Jasper. I'm a Linux system engineer as well as a Linux nerd. That's a combination you won't find in many places, and I'm hoping to continue my series of Linux tutorials in an effort to share tips and tricks, productivity hacks, and make your life a little bit easier, especially at the command line. I've built out a representative if statement for our purposes here. Let me cat this out. This is a file that I've saved on my computer. So if I want to process a shell script like this, which defines a function, rather than defining a function in line, I can actually source this file. So what source does is it kind of scoops up that command, or it scoops up that script file, and it'll process it. And because I defined a function in that script file, now that function is in working memory and I can use it and execute it. So from now on I'm going to be trying to do that. I should probably have done that in an earlier video when I introduced functions. But in any case, what's going on here? So let's examine this one, just because it has color output. So we see here we have an if statement. The part of the code that follows if is called the expression or the condition, and it's evaluated for what's called truthiness. I'm not trying to get into computer science, but basically this word will always evaluate to true, i.e. the if statement will always succeed, this expression will evaluate to true, and then this command will be executed. So if I run if demo, we see that that command is indeed executed. But what is true? True is actually a command, an executable file in Bash or in Linux, and it will always return true. When I run true, nothing seems to happen. But if I echo out what's called the status code, I see that true actually does return a value of 0. Status code is an integer that's returned by any command, invocation, any function, anything that the shell does. Anytime you hit enter, it's going to wait for status code, which indicates success or failure. In Linux, 0 indicates success, and by convention, true returns 0, meaning success, and that's interpreted as meaning true. There's also a false command, and as you can imagine, it can be run, and it also returns a status code. If we inspect that with the $? Variable, we see that it returns a value of 1. What's interesting is that this is actually the opposite convention of most other programming languages. So if I evaluate the Boolean value of 1, I get true, which is the opposite. As we saw, false is what returned 1, not true. True returns 0. But if I evaluate the Boolean expression of 0 in Python, we get false. So it's just something to keep in mind. Just keep in mind that that's the opposite convention. So if you've been familiarized with other programming languages, this is going to confuse you a little bit, but no worries. So what else is going on here? First of all, true and false are pretty much never going to be used in a real life use case for an if statement. These are really only useful for testing, evaluation, learning purposes, because if you knew that something was always going to be true, then you wouldn't even put it in an if statement, obviously. What is often paired with an if statement is the test command, which, like true and false, is also a command on Linux. It's an executable file. And, before we jump into that, let me hop back into Python, actually, and talk about what's actually an expression. So expressions in programming languages can often be evaluated for truthiness, for Boolean values. So Boolean values basically vary between 0 and 1, as we saw, 0 meaning false typically, and 1 meaning true. So for example, I could make an expression like this: 2 is less than 3. Python will interpret that expression, so it's not a command, it's not a function, it's an expression, and Python will determine that it is true. There are other types of expressions, especially in Python, which is pretty handy about doing math, multiplication. These operations return integer values, or double values, or decimal values. But we're interested in Boolean values. So if I do 3 is greater than 2, that returns a Boolean value of true, as we saw. The Boolean is really just 0 and 1. So this is just one of many different operations that are available in Python. I'm not trying to turn this into a Python lesson. Finally, we can also test for equality. So if I do 2 plus 2 equals 4, we see that Python is also able to sum these numbers before it evaluates the result with 4, and it correctly reports that 4 is equal to 4. Test is also able to do this. It's a little bit more clunky. So instead of the nice angle brackets, we have to use these bizarre options. LT meaning less than, and we have GT for greater than, and we have EQ for equals, but we can't place a 2 plus 2. Unfortunately, test is not that fancy. Okay, but again, we see that although the convention is precisely opposite, the result is really the same. The test command returns the truthiness of the expression that we give it, and that's exactly what it's used for in if statements. So, but mathematical expressions are not really where it is for test statements or the test command in Bash. It's possible, and I showed you how to do a couple different expressions, a couple different mathematical expressions using test, but really that's not really what we're trying to do. As system administrators, we're typically working with files and variables, and so we would do something like this, where we test for the existence of a bash RC file, which of course should exist since I'm running bash. I'm not running ZSH, okay, which is a different type of shell. So if I run that, I get a 1, which, as we learned in bash, specifically in bash, means false. I can also test for something like whether or not a file is executable. So for example, the bash shell, not text, but test, and I have to remember to display the status code. So we do have the bash shell available at that path, and it is executable, but we don't have ASH, which is a different shell, which I don't have installed, and we got a result of 1 from that. So what will typically happen in a bash script is that rather than a true or a false or a numerical expression, we'll see something like this. We'll see open and close brackets, and open and close brackets are an alias for the test command, basically. And that alias is made available strictly to follow the kind of the convention of other programming languages, where the expression to be evaluated is typically in parentheses, actually. In any case, you'll see that in the wild. In this case, if the bash RC file exists, then this command will be executed, which of course it will. And finally, let me just show you how to return your own status code. So I have another shell script here, another function. We see here that the return keyword, which is used by Bash basically to return a status code, will be used here. And if I run error and echo the status code, I get a status code of 1. And just to be completionist, I can replace that with 0, source it again, and run it again, and I get a status code of 0. So this rounds out the demonstration of if, test, and status codes. Hope you guys enjoyed it. Like, comment, and subscribe, and I'll see you guys next time.